Good morning, Mr. Lesham is here, and we are continuing with our exploration of calculus. Today we're going to see how we can use calculus. Let me just pause for a second. So yeah, we're going to learn, this is really probably the first time where we're going to apply calculus to do something which is very, very useful. I don't know if it will be as clear for you how useful it is, but it's extremely useful in our exploration of function. It is something that when you get to university, whether you do engineering, definitely any kind of science, you will use a lot, okay? And what we're going to look at is you've got a certain function, any function, a curve. You know that every curve is basically, there's a function behind it. And these functions can be really, really complicated, okay? So I took an example here, that's a cubic function, x cubed minus 2x squared plus 3. And if, let's say, we want to try and approximate, find out how would it behave close to a certain value of x. Let's say we choose x equal to. Now, this is quite complicated, but if instead of looking at that, we look at this line that kisses that point, what do we call that line? The tangent, okay? You see that red line, straight line that just kisses that point, the tangent. If we can just look at how this function behaves close to x equal to, then you can hopefully appreciate what I'm saying, that close to x equal to, these two curves are very, very similar. Okay, you can see that the red line, the red straight line, and the black curve are very, very similar in their values close to x2. As soon as I move away from x2, obviously they become very different. Okay? But physics and most science often is what we do is we take a complicated function and replace it with a very simple function, a linear function. Okay? And what our aim is to say, okay, what is that tangent? Okay, I know that tangent is mx plus c. So in other words, I'm trying to find the m and the c specifically when I'm looking at this function and x equal to. I hope that makes it. Does that make sense? Kind of. Okay, let's see what we'll do to me. So let's start with m. How do I calculate m? What is m? What is the m of a tangent? It's the gradient. It's the gradient, isn't it? Okay? Okay. So m is really the gradient, but it's the same gradient of this function, right? If you look at it, that's the whole definition of a tangent, that at this point, the gradient of the red line and the black line is the same. So really, it's the derivative of this function when x is equal to 2. So if I knew how to calculate the derivative, which I know, and then I would sub x equal to, that will give me my m. Okay? So how do we calculate the derivative? First of all, let's just find the derivative of any x. Okay? We've done that. Okay? Read it out for me. What will be the derivative of this function?
3x squared.
3x squared, okay, x cubed becomes 3x squared. By the way, was it supposed to be? Yeah, it is. Minus 4x. That's it. So that's what Simon already did for us, isn't it? Okay? 3x squared minus 4x. That's the derivative of this function at any x. At any x. How do we know what's the derivative when x is equal to? How do I do that? Just sub it here, okay? Not there, in the derivative. So it's going to be 3 times 2 squared minus 4 times 2, which I think, what is it equal? 12 minus 8 is equal to 4. So the derivative here is 4. In other words, what is m equal to? 4. So m is equal to 4. And then we know that the equation of the tangent is equal to, is y equal 4x plus a c, which I still don't know what the c is. Okay? Now, how do I find c? This is a problem we've done before. We've done these problems before. This is new. But how do I find this c? Of a tangent. I need to sub something, isn't it?
2.
Well, yes, I must sub 2. Okay, so I know that x is equal to 2. But what is the y? How would I find the y? How would I find what the y is? Simon showed you the equation. I need to sub x equal to, in which equation? In that, exactly. Because again, the thing about the tangent, they have the same gradient, but they go to the same point. Okay? So the y really, the y is basically the value of a function at x equal to which function? That one. Okay? So it's going to be 2 cubed minus 2 times 2 squared plus a 3, which is, what's that? 8 minus 8, which is equal to 3. Okay? So now write, okay, so y, when x is equal to, y is equal to 3. Okay? And I've got c equal 3 minus 8, which is minus 5. Okay? I will explain it again, don't worry. Finally, I've got all the pieces of the puzzle, right? M is equal to 4, C is equal to 5. I can write down, I'll write it down here, y is equal to 4, right? M is equal to 4, x minus 5. That's the final answer. Okay, so I'm just going to pause here. So now I'm going to show you how to do it in a slightly different way. Okay? Now what do I mean slightly different way? Calculating the gradient, calculating the M, you got to do the same. There's no difference here. But now, instead of, you know, so at this point, I know that y is equal to 4x plus a c. Instead of going the same route as subbing an x and the y and finding out what the c, which is the way I taught you since grade 9, okay? Now we're going to use another formula, and I want you to remember that formula, okay? Y minus y1 equal mx minus x1. This is the formula of the okay? So this, from now on, I think it's, I mean, you can carry on as I taught you just now, or as I told you in grade 9, but I think it is worthwhile remembering this formula as well, okay? What is this formula? This is equation of a tangent, okay? So let's start with M. M, I know what it is. What is M? It's the gradient. And in this case, it's 4. Okay? Now, y and x are variables. You know, in any equation of a tangent, I have a y and an x. I don't need to put numbers in them. Otherwise, it's not going to be an equation. So y and x are just y and x. What is the x1 and the y1?
The value is
it's the point. What did you call it, Simon? It's the point of contact, okay? So x1, y1 is point, we'll call it point of contact, okay? It's basically this. This is the x1, y1. You will always be told what is the point of contact. Well, I might not tell you what the y is, but I certainly have to tell you what the x is, okay? So the tangent is going through this point of contact, okay? In this case, I know they told me that x1 is equal to 2. How would I find y1? Now you should be able to tell me because I asked you that question before. How do I find y1? How would I find this y? Sub where? In the function. So sub in the original function is basically the value of the function at x equal 1, which is in this case, what was it? Okay, so 2 cubed minus 2 times 2 squared plus 3. I think we got, was it?
3. Yeah.
It's 3, yes, because, yeah, so we didn't actually calculate it before. Oh, we did. Okay, so that's 3. Okay, so the point of contact really is 2, 3. That's the point of contact. Point of contact. Okay, so that's the point of contact. M, what was M? What did we say the M is?
4.
Yeah, it is 4 in this case, but what does it mean then? Gradient, but not just gradient of tangent. Okay? So now I just put everything in this formula. I'm going to write y minus, what is y1? Have a look here, what is y1? 3. Equal m, what is m? We said 4. I'm not going to ask you again, you told me that. X minus x1, what is x1? 2. Okay? So when you write that, you're pretty much there. Don't leave it like that because we never write equation like that. But from now, it's just very, very simple. We're going to say, okay, y is, or let's put it in 2 stages. Running out of space here, guys. If I write here, I'm going to see it, and we'll see it. So y minus 3 equal 4x minus 8. I just opened the brackets. 4x minus 8. Move the 3 to the other side. Y equal 4x minus 8 plus this 3 is minus 5. obviously I'm getting the same answer as I calculated in the old method. Okay, which method is better? It's up to you. If you're good at memorizing, I think it's worthwhile remembering that. Okay. Cheerios. Bye-bye.